Hi everyone, my name is Takudzwa Comfort Madzivanzira. I'm a postdoc based at the University of Mpumalanga in South Africa, and I'm funded by the South African Institute for Aquatic Biodiversity, which is one of the leading institutes in aquatic biodiversity research in Africa. My talk is on crayfish invasions in Africa, work that I did for my PhD supervised by Dr. Joseph South, who is now based at the University of Leeds, and the late Professor 𝐸𝐸𝐸𝐸. So our continent, which is naturally devoid of native crayfish species, except for Madagascar, has been a recipient of 9 crayfish species, with 5 of those, as shown in the map legend, establishing naturalized populations in 14 African countries. The main drive of these introductions was to provide socio-economic benefits through fisheries and aquaculture development, but however, there isn't enough evidence of success. Regardless of the original purpose of introduction, these crayfish species often end up in our important freshwater systems. I'm going to give you an example of one notorious crayfish species, that is the Australian red-claw crayfish, 𝐚𝐰𝐴𝐸𝐸𝐸𝐸, which is native to Northern Australia, as well as southeastern Papua New Guinea. So populations that are established in the Sand River Dam in Swaziland and 𝐚𝐼𝐸𝐸𝐸𝐸 River Basin in South Africa were a result of escapees from an aquaculture facility in Swaziland. The same thing happened in Kafue River and Lake Kariba in Zambia and Zimbabwe, whereby crayfish that were being kept at aquaculture facilities in Zambia escaped into the 2 river systems. Recently, we reported an invasion of the Barossa floodplain in Zambia, which was due to crayfish that were being kept by road construction workers, which escaped into the Barossa floodplain during the annual floods. So this is the case with other crayfish species, for example, the red swamp crayfish, which has also established in several basins in Africa. But why should we be concerned in Africa about these crayfish invaders? It's because invasive crayfish species have generally been shown to negatively impact native species across different levels of ecological organizations. These are documented widely outside Africa, and in our continent, literature on crayfish impact is scant, and this does not do us a favor as conservationists, as there isn't enough evidence to compel our policymakers against the introduction. To fill in this knowledge gap, I conducted several lab experiments to determine the potential ecological and socio-economic impacts conferred by the red claw and the red swamp crayfish, which are 2 species that are rapidly spreading across the continent. I described consumer resource dynamics of the 2 crayfish species in comparison to a native trophic analog, the freshwater crab of the Potamonatus genus, preying on various native taxa, ubiquitous to African terrestrial and aquatic ecosystems. I conducted the functional response under dark conditions, as the 3 decapods are nocturnal and highly active during the night. I used the temperature treatments 19 and 28 degrees Celsius, which represents winter and summer averages in the invaded systems in Southern Africa. So this is the functional response comparison of the 3 decapods under light and dark conditions, showing that the per capita consumption was significantly higher during the dark, which confirms the nocturnal nature of these decapods. So this is the catfish fry FR at 19 and 28 degrees Celsius. And in most cases, FR increased with temperature, except for crabs, only for this experiment. The FR, in most cases as well, was not significantly different, especially at the higher prey densities. This is the FR on terrestrial earthworms, whereby the FR for crabs was significantly higher than that of the two crayfish species at the low temperature only. This is the FR on chironomids and the FR on mosquito larvae. This one was a consumption experiment using the aquatic macrophytes pondweed as a resource, and is hypothesized based on literature. Consumption by 𝐸𝐸𝐿𝐴𝐶𝐜𝐸 was significantly higher than that of the other two decapods at both temperature treatments. This one was a scavenging experiment using the tilapia Oreochromis or mozambicus as a resource. And in this experiment, damage by the red claw was significantly higher than that of the other two species. So I conducted this experiment after we received reports from fishermen about how crayfish are affecting their catch. And this photo was taken from the invaded 𝐸𝐿𝐴𝐶𝐸 River. And you can see how crayfish are spoiling catch, resulting in fish that are not marketable. These are pictures that I took from my lab experiment to show the damage between the three decapods. So impact on fisheries is incurred as crayfish are attracted to fish caught in the gill net and will partially consume the catch while simultaneously spoiling the value of the catch. In doing so, crayfish often become entangled in the fishing gear, damaging the nets and decreasing their fishing efficiency. So all this, it poses a significant threat to food security in Africa. I further estimated the economic losses due to crayfish, which translated to more than $500,000 United States in Lake Kariba per annum, and approximately $2 million United States in 𝐸𝐸𝐿𝐴𝐶𝐸 River. So it is important to document these economic losses as they are more easily perceived and more likely to be addressed by the policymakers. So my data provides novel evidence on where these crayfishes are, where they are heading to, and their devastating impacts and potential impacts on ecosystem services owing to their high functional responses and consumption rates. Crayfish are likely to spread even more to important ecosystems, for example, the Okavango Delta in Botswana and Lake Malawi in Malawi, which all contain marvelous biodiversity. Further to the per capita impacts, crayfish are likely to bring additive pressure to resources that previously were not threatened by native crabs only. Also, under the warming scenarios, as predicted, crayfish are likely to expand their invasion ranges and cause more deleterious impacts. Owing to the evidence I have provided, governments, policymakers, environmental managers, communities should all maximize efforts to prevent the introduction and spread of crayfish. Scientists, on the other hand, let's also direct our researchers to provide solutions to avert invasions and associated impacts. I would like to thank various individuals, organizations, and funders. And for further information, you can get in touch with me on my contact details, which are below. Thank you, ladies and gentlemen, and I would like to end my presentation by honoring my late supervisor, Professor 𝐸𝐿𝐴𝐶𝐸.